Good morning, good afternoon, and good evening. Welcome to the ESCRT Reader's Briefing, the podcast that turns a full issue of a major magazine into a focused 30 to 60-minute audio briefing. Today, we are bringing you a reader's guide to the August 6th, 2026 issue of Nature. This issue's cover presents an immense ocean bloom viewed from space. At first glance, the image appears almost beautiful, but the scientific question behind it is much more complicated. Could deliberately adding iron to parts of the ocean stimulate phytoplankton growth, draw more carbon dioxide out of the atmosphere, and help slow climate change? And if it could, what ecological costs might follow? The cover therefore places the potential climate benefits of ocean iron fertilization beside its environmental risks. It also points toward three other major lines of inquiry in this issue: how scientific papers move into patents and commercial innovation, how nuclear-powered merchant ships could be governed safely across national borders, and why medical artificial intelligence training data may expose some patients to greater privacy risks than others. From extreme climate events and global health institutions to marine geoengineering and nuclear shipping, this issue revolves around five major questions. First, by how much could the next El Niño break existing records? And if it does, how could the resulting heat affect global temperatures, extreme weather, and long-term economic losses? El Niño is not simply a temporary change in ocean temperature. A sufficiently powerful event can influence rainfall, drought, storms, agriculture, energy demand, infrastructure, and economic activity across large parts of the world. The deeper question is whether warming oceans are changing the upper limits of what an extreme El Niño can become. Second, why does the world need the World Health Organization more than ever? Global health threats do not respect national borders. Disease surveillance, outbreak reporting, vaccination, technical standards, emergency coordination, and support for weaker health systems all depend on institutions capable of working across countries. The more fragmented international cooperation becomes, the more important the question of who maintains those shared capacities becomes. Third, how should the climate benefits and ecological costs of ocean iron fertilization be weighed? Adding iron can stimulate phytoplankton growth in some nutrient-limited waters. That growth may absorb carbon dioxide. But changing marine productivity at large scale could also alter food webs, oxygen levels, nutrient cycles, species composition, and the movement of carbon through the ocean. A climate intervention cannot, therefore, be evaluated only by asking how much carbon it might remove. It must also be judged by what else it changes. Fourth, can algal blooms really help fight climate change? This question sounds similar to the previous one, but it goes deeper into the biological mechanism. For a bloom to produce lasting climate benefits, carbon captured near the ocean surface must remain out of the atmosphere for meaningful periods of time. That depends on what happens after the algae grow. How much carbon sinks? How much is rapidly recycled? Where does it go? And what ecological consequences occur along the way? Fifth, what risks must plans for nuclear-powered merchant ships confront? Nuclear propulsion could reduce dependence on fossil fuels for some forms of shipping, but civilian nuclear vessels would also cross jurisdictions, enter ports, require specialized crews, manage radioactive materials, and operate within international insurance, liability, emergency response, and security systems. The engineering challenge is only one part of the problem. The other is whether governance can keep pace with the technology. Taken together, this issue of nature moves across very different timescales. El Niño can reshape weather within months. Ocean ecosystems may respond over years or decades. Public health institutions must remain functional across generations of crises. Scientific discoveries can take years to move from papers into patents and products. Artificial intelligence systems can create privacy risks almost instantly, and nuclear-powered commercial fleets, if built, could remain in service for decades. Across climate science, marine ecology, public health, research governance, artificial intelligence, life science, and materials technology, one conclusion repeatedly appears. Scientific possibility is not the same as responsible deployment. A technology may work in principle and still create unacceptable risks. A climate intervention may remove carbon while disrupting ecosystems. A medical artificial intelligence system may improve analysis while exposing vulnerable patients. A nuclear-powered ship may reduce emissions while creating new regulatory and security obligations. And a scientific discovery may have enormous commercial value while raising difficult questions about ownership, access, and public benefit. The central challenge is therefore not only whether science can solve a problem, it is whether institutions can decide where, when, and under what conditions a solution should be used. Next, we turn to the individual article briefings in this issue.
Section 1. Global Climate, Environment, and Agricultural Resilience. This section begins with the strengthening El Niño, global heat, extreme weather, and economic losses. Then examines carbon removal, oxygen depletion, nutrient redistribution, and ecological recovery under ocean ion fertilization. It also turns to cold protection of pollen, forever chemicals, late Triassic wildfires, and rift valleys on Venus. 1.1. The largest on record by a mind-blowing margin. What to expect from the next El Niño? The El Niño pattern strengthening in the Pacific was on track to become the largest in at least 150 years. Researchers said that, if the extreme forecasts proved correct, heat released from the ocean, combined with human-caused warming, would probably make 2027 the hottest year on record and trigger extreme weather across many regions. The United States National Oceanic and Atmospheric Administration put the chance of a very strong event by the end of the year at 4 in 5 and said El Niño conditions would almost certainly persist until at least April 2027. 14 climate models produced a median peak sea surface temperature about 0.8 degrees Celsius above the 2015 to 2016 record. The models suggested a tropical Pacific peak around 6 degrees Celsius above average, compared with the previous record of 2.75 degrees Celsius. This outcome was not inevitable, but its probability was rising month by month. If the forecasts were broadly correct, the event could cause $10 trillion in economic losses by 2032, strain ecosystems and oceans, reduce net carbon uptake, and further damage heat-bleached coral reefs. Its close spacing, only 2 years after the previous El Niño, also raised the unresolved question of whether global warming is beginning to alter the El Niño Southern Oscillation itself. 1.2. Climate benefit and ecological cost trade-offs for ocean ion fertilization. Ocean ion fertilization is being discussed as a possible carbon dioxide removal strategy, but its climate benefits and ecological costs remain poorly understood. The study found sharp regional differences, with similar removal efficiencies producing very different ecological outcomes. The Southern Ocean and Equatorial Pacific delivered the highest efficiencies, but fertilization in the Equatorial Pacific reduced energy reaching higher trophic levels, expanded oxygen minimum zones, and lowered large zooplankton biomass. Moving fertilization to higher latitudes could avoid some of these effects. Recovery experiments showed resilience in the Southern Ocean, whereas ion retention prolonged disturbance in the Equatorial Pacific. The Southern Ocean combined higher efficiency with lower risk. The equatorial Pacific and global fertilization combined high efficiency with high risk, and subtropical waters offered low efficiency with moderate risk. After 60 years, the MET removal corresponded to an atmospheric decline of 1.1 to 5.3 parts per million, but more than half would be released again within decades after fertilization stopped. Distant and delayed effects would also complicate carbon accounting, ownership of benefits, fairness and governance. 1.3. Can algal blooms fight climate change? If carbon dioxide cannot be removed from the atmosphere at large scale, global warming may be difficult to hold within the Paris Agreement limits of 1.5 or even 2 degrees Celsius. Ocean ion fertilization has therefore returned to climate discussions, but it is not a simple technical answer. It is a controversial intervention involving carbon storage, marine ecology, and cross-border governance. Simulations found the highest carbon removal in the equatorial Pacific and Southern Ocean, yet their ecological consequences differed. The Southern Ocean showed smaller impacts and the most complete recovery after fertilization stopped, whereas the equatorial Pacific experienced greater nutrient loss, expanding oxygen depletion, and less energy at higher trophic levels. Even a lower risk location would not solve the governance problem because damage could appear later and far from the intervention site. About half of the removed carbon was released again within the 60-year study period, in stark contrast with fossil fuel carbon that can remain in the atmosphere for thousands of years. Ocean ion fertilization might therefore be unsuitable for offsetting such pollution. Responsible deployment would require governance questions to be treated as seriously as scientific ones. 1.4. Cold-induced peptide signaling secures pollen resilience and crop yield. Cold weather can cause severe crop losses, and climate change is increasing the frequency and unpredictability of these events. Pollen failure during flowering is a major source of yield loss, but the molecular basis of cold tolerance had remained unclear. Researchers identified a group of cold-responsive small signaling peptides in tomato, including SLRGF9 and SLRGF10 from the RGF, GLV and CLEL family. Plants lacking these peptides appeared normal under ordinary conditions, but developed pollen sterility under cold stress. At the cell surface, the receptor-like kinase SLRGFR6 and SLSERK proteins formed a complex that bound cold-induced SLRGF. The pathway activated calcium influx through cyclic nucleotide-gated channels, countered delays in programmed cell death, and ensured timely degradation of the tapetum so that microspores could develop. Increasing SLRGF9 and SLRGF10 expression prevented as much as 52% of cold-related tomato yield loss. The pathway was conserved across dicots and monocots, and increasing related RGF genes in rice improved pollen cold tolerance and recovered 18.3% of grain yield loss.
1.5. Inescapable. Inescapable perfluoroalkyl and polyfluoroalkyl substances are known as forever chemicals. They circulate through rainwater and soil, and their carbon-fluorine bonds are extremely difficult to break. Perfluorooctanoic acid, a key material used to make Teflon, is also carcinogenic. In Maine, a state identified with farms, forests, and waterways, these chemicals can persist in water, soil, and the wider environment. A family's drinking water, livestock feed, and farm products can all lie on the same contamination pathway. By the time health risks and market losses become visible, releases may have continued for years, and both responsibility and chemical sources may be hard to trace. Because these bonds are so resistant, remediation often costs far more than the chemical's original use. The deeper problem is an institutional sequence in which society uses a substance first, understands it later, and ultimately pays for the cleanup. 1.6. Wildfires swept across Europe at end of the Triassic. About 200 million years ago, during the mass extinction that ended the Triassic period, fern-covered landscapes dried out and fueled enormous wildfires across Europe. Researchers examined sediment cores from 4 European sites. Around the time of the extinction, fern spores in every core turned dark brown, and other plant fossils carried the same marks, indicating widespread burning rather than a local event. The team concluded that global warming first encouraged ferns to spread, then high temperatures dried them out and allowed them to burn across large areas. The authors noted that late Triassic conditions resemble factors that are increasing fire severity in today's warming world. 1.7. Rift valleys could be keeping Venus active. Models of Venus indicated that its surface rift valleys formed within the past tens of millions of years and might still be forming today. This challenged the theory that Venus is no longer tectonically active. Venusian rifts have steep, uplifted sides and are generally wider than those on Earth. The models linked this geometry to a strong, thick lithosphere extending rapidly. They also showed that rifts gradually relax after forming until their sides become difficult to distinguish from the surrounding terrain. The most detailed observations have not yet detected active geology directly, but the modelling suggested that rifting on Venus could still be continuing.
Section 2. Biotechnology, Cells, and Molecular Engineering. This section focuses on programmable molecular tools and cellular systems, including cancer-specific RNA-triggered chromatin shredding, the de novo design of small molecule binding proteins, spatial proteome maps of the human body and cancers, and lysosomal membrane repair. 2.1. Targeting cancer-specific mutations with RNA-triggered chromatin shredding. Cancer-driving mutations often occur in tumor suppressors such as p53, which is altered in roughly 40 to 50% of cancers. These mutations are difficult to target because the proteins often lack a clear drug-binding pocket, and restoring their original function is challenging. Researchers programmed Cas12a2 to recognize cancer-specific transcripts and selectively kill cancer cells. Activation triggered collateral chromatin shredding, a DNA damage response, and cell death. Guide RNAs designed for single nucleotide TP53 variants allowed Cas12a2 to kill cells carrying specific point mutations. A guide against TP53 R280K inhibited only cells with that mutation and produced no detectable growth inhibition or DNA damage in wild-type cells or cells carrying another TP53 mutation. In an early lung tumor model, mutation-targeting lipid nanoparticles produced a larger, statistically significant reduction in tumor signal without obvious damage to the lung or other organs. In a later stage model, lung tumor signal did not fall, although metastasis was delayed. Limited delivery and advanced tumor burden therefore remained major constraints. 2.2. DNA shredding enzyme takes aim at cancer cells. 2 studies showed that Cas12a2 can be programmed to detect mutations in disease-related RNA and trigger DNA destruction only in cells expressing that RNA. The target RNA acts as a switch, and the enzyme remains inactive when no complementary target is present. By directing guide RNAs to disease-specific transcripts, researchers cleared diseased cells in culture and animal models while sparing healthy cells. Both studies showed that Cas12a2 could distinguish RNAs differing by a single nucleotide. the approach still carries serious risks because activated Cas12a2 broadly degrades DNA and must be restricted to the correct cells. In vivo coverage will set the upper limit of efficacy, and repeated dosing could provoke immune responses or alter tissue exposure. Delivery, therefore, cannot be solved simply by increasing the dose. 2.3. Zero-shot design of drug-binding proteins via neural iterative selection expansion. Researchers combined two neural networks in an iterative design algorithm that could create highly accurate small molecule binding proteins from scratch. Using different protein folds, the method achieved a 100% success rate for exatecan and 83% for apixaban. Compared with previous leading methods, affinity improved about 70-fold for exatecan binders and nearly 10,000-fold for apixaban binders. The neural network then proposed two amino acid substitutions that increased the affinity of the strongest exatecan binder another 100-fold without any experimental input. The optimized binder protected exatecan's unstable lactone ring from hydrolysis for several days. Custom proteins can therefore do more than capture small molecules, they can also change their stability and useful lifetime. 2.4. Spatial distribution of the proteome in the human body and in cancers. A deeper understanding of human biology and disease requires a detailed, quantitative, spatially resolved proteome map. Using data-independent acquisition mass spectroscopy, researchers analyzed more than 13,000 proteins in 2,856 samples and built a comprehensive human proteome landscape. The data covered 58 major tissues, 251 specific tissue subtypes, and 25 cancers. It traced spatial proteome trajectories across fetal tissue, tumors, tumor-adjacent non-tumor tissue, and healthy adult tissue, revealing both development and tumorigenesis. Quantitative comparisons across tissues and states can indicate organ-specific toxicity, identify drugs that might be repurposed for cancer, and help prioritize therapeutic targets. The study produced a navigable quantitative proteome resource for the human body and common cancers. 2.5. Laser couples damage sensing to ESCRT assembly for lysosome repair. After lysosomes were damaged and released calcium, the laser complex formed rapidly and linked membrane damage sensing to ESCRT-dependent repair. TFG sits at the core of laser. When bound to ATG8 proteins, TFG formed oligomers and directly recruited TSG101, an essential ESCRT-I subunit, through a conserved motif. The TFG and TSG101 interaction promoted sequential assembly of ESCRT, ESCR2, and ESCR3 and drove membrane repair. TFG mutations that cause hereditary spastic paraplegia disrupted oligomerization, weakened ESCRT recruitment to lysosomes, and impaired membrane resealing. This connected a specific repair defect with TFG-related neurodegenerative disease.
Section 3. Medicine, Public Health and Healthy Longevity. This section begins with international health cooperation and the World Health Organization's 80-year history, then covers an Ebola vaccine trial, health system financing during European heatwaves, DNA repair and healthy longevity, cancer metastasis, aging, inflammatory bowel disease, autism and pain. 3.1. Why the need for the WHO has never been greater. Diseases do not stop at borders, and pandemics, climate change and conflict require collective action. Over 80 years, the World Health Organization worked with more than 190 member states and other partners to eradicate smallpox, advance the elimination of polio, expand access to life-saving vaccines, and lead the global response to HIV. Average life expectancy is now more than 25 years longer than it was 80 years ago. The COVID-19 pandemic, the most severe health crisis in a century, showed that no country can confront such threats alone. The WHO's strength lies in bringing together health leaders, scientists, and the global health community, setting standards, finding solutions, and coordinating action in crises. Member states again demonstrated that value by adopting the WHO Pandemic Agreement, which applies lessons from COVID-19 to improve equity and preparedness. In 2025, the United States gave notice that it intended to leave the organisation. Member states had already agreed to raise assessed contributions from 16% to 50% of the core budget over time, an important step toward financial independence. As the WHO enters its 9th decade, digital technology will be central, while conflict, climate change, displacement, non-communicable disease, and antimicrobial resistance continue to grow. The world needs a science-led, evidence-based, impartial, and globally representative health organisation more than ever. 3.2. Trials for the Ebola vaccine have started 3 months after the outbreak began. The University of Oxford vaccinated the first participant in a Phase 1 clinical trial, and lead scientist Theresa Lam described how the team moved so quickly. On the 24th of July, the first volunteer received a vaccine against Bundibugyo Ebola virus, only 68 days after the World Health Organization declared the outbreaks in the Democratic Republic of the Congo and Uganda a public health emergency of international concern. By the 27th of July, officials had confirmed 3,200 cases and 1,405 deaths in the Democratic Republic of the Congo alone. The vaccine, ChAdOx1, uses the same vector platform as the Oxford AstraZeneca COVID-19 vaccine, but carries genetic instructions for a Bundibugyo Ebola virus protein. About 620,000 doses had already been manufactured. The trial was designed to assess safety and immune responses before a larger study in Uganda later in the year. 2 other vaccines were also in development, an mRNA vaccine from Moderna, expected to enter clinical trials that month, and a vaccine from the International AIDS Vaccine Initiative, resembling the vaccine recommended for Zaire Ebola virus. All 3 programs were funded by the Coalition for Epidemic Preparedness Innovations. 3.3. Put health systems at the centre of European heatwave plans. Extreme heat is becoming a persistent silent killer in Europe. Unlike floods or storms, heat waves leave little visible destruction, yet they quietly increase cardiovascular, kidney, and mental health risks and place greater pressure on healthcare systems. European heat plans remain too narrowly focused on cooling technology, building design, school closures, and urban greening. These measures are necessary but insufficient because extreme heat is first a health system shock. Its effects continue after temperatures fall, increasing admissions, delaying existing care, placing staff under pressure, and requiring long-term investment in cooling, prevention, and resilient health infrastructure. Europe is warming at more than twice the global average, so adaptation must include explicit health financing plans. Heat preparedness should involve health system stress tests, estimates of heat-related expenditure, and funds arranged in advance for local public health responses. Heat resilience deserves the same seriousness in fiscal planning as defence and education. 3.4. Could mending damaged DNA prolong life? Unrepaired or incorrectly repaired DNA damage can introduce mutations and contribute to cancer, and DNA damage also appears to be a major driver of aging. Scientists studying DNA repair argued that the idea of strengthening repair was beginning to look promising. In mice, dietary fucoidan improved DNA repair, reduced cellular senescence, and extended both health span and lifespan. The DREAM complex appears to be a master regulator affecting many repair systems. However, extensive work is still needed to determine whether it can be targeted and how best to do so. Enhancing DNA repair might address both cancer and other aspects of aging, but no evidence yet shows that this dual benefit can be achieved. A further limitation is the lack of direct markers of DNA repair. 3.5. Steatosis shapes prognosis-defining liver metastases heterogeneity in CRC. Liver metastases is the most common cause of death in colorectal cancer. 5-year survival was below 44.2% for patients with replacement-type metastases, compared with 73.4% for those with encapsulated lesions. Researchers found that hepatic steatosis changed the growth pattern of colorectal cancer liver metastases and promoted the poorer prognosis replacement type. A metabolic state driven by fatty acid oxidation stabilized the transcription factor MYC. Intervening at these separate nodes suppressed replacement-type lesions, showing that the metabolic and tissue-level features depended on mechanisms that could be separated. Patient-derived and mouse models both showed that targeting these dependencies could limit replacement growth. Liver fat imaging and pathological growth patterns could therefore identify high-risk patients more likely to depend on this pathway before targeted drug testing. Steatosis shaped prognosis-defining metastatic heterogeneity while exposing an actionable metabolic weakness.
3.6. Mechanism of age-related accumulation of mtDNA mutations in human blood. Mitochondrial DNA single nucleotide variants began to rise markedly around the age of 60 and generally remained at low heteroplasmy. The sequence pattern was more consistent with errors arising during mitochondrial DNA replication than with damage caused by reactive oxygen species. Researchers proposed a two-step model. First, replication errors generate hidden mutations in blood-forming cells. Second, as people age, clones carrying those mutations expand and increase their share in blood samples. Because the study mainly used bulk sequencing of mixed blood cells, it could not identify the exact cell type carrying each mutation, or fully reconstruct the timing of mutation and clonal expansion. Single-cell and longitudinal studies are still needed. 3.7. Cell type resolved genetic variation shapes inflammatory bowel disease risk. Much of the genetic risk for inflammatory bowel disease comes from variants that do not change protein coding sequences. The study built a cell-type resolved expression quantitative trait locus map linking genetic variation with gene expression in immune and intestinal epithelial cells. Many regulatory effects appeared only in particular cell types and would be diluted or hidden when cells were analyzed together. Cell-type resolved expression quantitative trait loci showed more than a 3.5-fold increase in co-localization with inflammatory bowel disease association signals. Researchers could therefore nominate possible effector genes for more than half of the risk loci. The maps can distinguish causal candidates from genes that merely sit near a risk locus and can inform drug target selection. However, co-localization and expression association alone do not prove causality, and functional experiments are still required. The current map also does not cover every rare cell type or environmental state. 3.8. Cortical development dynamics across autism spectrum disorder mouse models. Autism spectrum disorder can arise from many genetic changes, and a central question is how different risk genes produce shared or distinct effects during brain development. Convergent effects were strongly specific to developmental stage and cell type. the most consistent early signal appeared in radial glial lineages. Several risk genes produced a temporary developmental delay that altered the timing of progenitor transitions into neurons and glial cells. This early delay gradually eased after birth, and at later stages, many cell proportions and transcriptional states approached control levels, suggesting some developmental compensation. Mouse models cannot fully represent human autism, and single gene models cover only part of its genetic architecture. The convergent changes must still be tested in human tissue, organoids, and longitudinal data. 3.9. Diverse binding poses of agonistic neurotoxins on human NaV1.6. The voltage-gated sodium channel, NaV1.6, is widespread in the nervous system and is crucial for generating and propagating action potentials. Using cryo-electron microscopy, researchers resolved complexes formed by 3 agonist peptide toxins with human NaV1.6 and its beta-1 auxiliary subunit. All 3 toxins enhanced NaV1.6 activity, but they did not share a single binding mode. This diversity showed that peptide toxins can control the same ion channel through several structural entry points. NaV1.6 is implicated in pain, epilepsy, and other neurological disorders. A precise understanding of how agonist toxins stabilize channel states could provide templates for inhibitors, modulators, and research tools. 3.10. Blood disorder linked to fast-aging stem cells. Researchers found that blood-forming stem cells in mice with sickle cell disease showed signs of chronic stress, DNA damage, and premature aging. Existing cancer drugs and anti-aging treatments could reverse those signs. Stem cells from both mice and people with the condition displayed molecular evidence of premature senescence, a state in which cells stop dividing but are not removed. Treating mice and human cells with the cancer drug navitoclax restored stem cell function to levels close to controls without sickle cell disease. The combination of dasatinib and quercetin, previously shown to reduce senescence, produced the same restorative effect in mice. 3.11. Tell me where it hurts. Pain is a complex phenomenon. Pain scientist Rachel Zoffnis wrote that pain can feel stronger when people are lonely and sad than when they are happy and surrounded by loved ones. The book includes vivid and complicated cases. One construction worker jumped from a plank and landed on an 18-centimeter nail that passed through his boot, causing extreme pain. After doctors sedated him and removed the boot, they found that the nail had passed harmlessly between his toes and had not even scratched his foot. The episode showed that pain is not a direct readout of tissue damage. Visual cues, expectation, fear, emotion, and the social environment can all change the intensity of pain a person experiences.
Section 4. Science Policy, Research Governance, and the Innovation Economy. This section examines how institutions organize science and technology, covering nuclear-powered merchant ships, United States research funding and science planning, European bioengineering, democratic accountability under polarization, the movement of academic papers into patents, and management training for laboratory leaders. 4.1. Plans for nuclear-powered merchant ships must confront risks. Nuclear power emits no carbon dioxide during operation and does not require ships to carry thousands of cubic meters of fuel, leaving more space for cargo. It can also eliminate refueling stops and increase speed, shortening voyages and potentially saving ship owners tens of millions of dollars per vessel each year in marine fuel and carbon taxes. But a merchant ship with a reactor is a mobile nuclear facility and must be treated with exceptional care. It could be hijacked, grounded, or struck by a missile. Such ships might be designed in one country, built in another, sail under a third country's flag, be insured in a fourth, enter many foreign ports, and eventually be dismantled where safety procedures are weak. Collisions, fire, flooding, loss of power, grounding, and cyber intrusion could affect both ship and reactor. In dangerous waters, threats also include drones, missiles, armed boarding, crew evacuation, refusal of port refuge, and delayed salvage. The reactor must shut down automatically after severe impact, fire, flooding, propulsion loss, or communications failure, and should remove decay heat for days or preferably weeks without crew action, shore power, or access to the reactor compartment. Ports must also address fuel and waste liability, insurance, and the grounds for suspending access. The International Maritime Organization and International Atomic Energy Agency need a shared framework rather than two confusing systems. 4.2. White House rolls out AI funding amid cuts to many other fields. On the 21st of July, Presidential Science Advisor Michael Kratsios released Science, A New Golden Age, proposing major changes to federally funded research. The next day, he helped announce the first awards under the government's flagship artificial intelligence program, the Genesis mission. About 5,000 teams applied, and the government compared the program's urgency and ambition with the Manhattan Project, saying it would use artificial intelligence to accelerate American science. Officials announced roughly 280 first-round projects, each receiving $500,000 to $750,000 for 9 months to address problems such as improving the power grid and automating laboratories. At the same time, the National Science Foundation had reclaimed $300 million from its mathematics and physical sciences and computer and information science divisions. Program officers withdrew 150 proposals that had already passed peer review, cancelling some, cutting others, and postponing the rest. The Genesis mission plans to build an artificial intelligence platform linked to data, instruments, and supercomputers at 17 national laboratories. Its total funding and spending plan remained uncertain. The White House announced $5 billion but did not identify the source, leaving a gap between the program's rhetoric and its actual resources. 4.3. What's missing from the White House plan for the future of U.S. science? Michael Kratsios, head of the United States Office of Science and Technology Policy, released a 123-page report titled Science, A New Golden Age. It raised important questions about supporting the research behind technological progress, strengthening scientific infrastructure, using artificial intelligence in science, and reforming grant allocation. Unlike the landmark 1945 report, the new document did not name the scientific or technical communities consulted. The Trump administration had already sharply reduced channels through which independent specialists advised the federal government. The proposal also showed no direct evidence of input from the national academies or disciplinary scholarly societies. Its vision omitted key areas, including climate change, public health, and the social sciences, even though climate change and emerging infections will have enormous consequences, and the social sciences and humanities will be essential for navigating artificial intelligence. The annex also avoided terms such as world, global, and international cooperation. It seemed to assume that American science could enter a golden age while cut off from researchers elsewhere, an idea contradicted by roughly 75 years of evidence. Science is not confined by national borders and should not be. The report's failure to embrace that principle was a missed opportunity. 4.4. How to turbocharge bioengineering in Europe. Europe is losing ground in one of the most innovation-intensive areas of biomedicine and healthcare, bioengineering. Across the 27 European Union member states, there are fewer than 10 fully independent bioengineering departments, compared with more than 100 in both the United States and China. The European Union should establish dedicated bioengineering funding programs and review panels, and involve experts from the field in designing future initiatives. Both the Union and its member states need targeted funding, public-private investment, tax incentives for technology investment, and fewer administrative barriers to technology transfer. They also need regulatory pathways that preserve safety while making early clinical approvals more efficient. By building autonomous departments, specialized funding and review mechanisms, links to industry and capital, and a safe but efficient path to clinical translation, Europe could preserve its strength in life science and turn more research into technologies patients can use.
4.5. How scientists can tackle the paradox of polarization. The greatest challenge for science in public policy is how to govern forms of research that most people do not understand. Paradoxically, deep dissatisfaction with technocratic rule by experts has fueled populism and polarization and weakened public trust. The administration of President Donald Trump sought to replace peer review with political oversight, but that approach would not produce effective knowledge either. Applicants could instead explain both the innovative potential and possible risks of their plans when submitting them, bringing social consequences into review earlier. Review panels could then refer contested points to policymakers. The purpose would not be for experts to make value choices on behalf of the public, but to identify projects that require open discussion before investment expands. Scientists would then be seen as providing research that serves democracy. 4.6. The most cited science papers in patents. A 1975 paper explained how to produce monoclonal antibodies at scale. These antibodies later became indispensable tools in biological research and the basis of major treatments for cancer, autoimmune disease, and infectious disease. The paper was cited by more than 17,000 academic articles and mentioned in more than 13,000 patent applications, ranking 5th among the scientific papers most cited by patents. Yet patent procedure and citation practices create many surprises, and the flow of knowledge from research to patents does not represent a simple causal relationship. The analysis nevertheless showed the influence of academia on industry. Most of the papers most heavily cited by patents came from publicly funded research. Counting only front-page patent citations substantially underestimated the commercial influence of academic science. When citations in the body of patents were included, the share rose to 44%. 4.7. Scientists don't need more trust, they need allies. A news feature reported that scientists are broadly trusted but may be losing the contest for influence. Research showed that combining scientists' voices with those of the public can change that outcome. Scientific support was influential across the political spectrum, but when government and industry opposed a proposal, support from scientists alone could not save it. When citizens and scientists jointly supported an idea, however, 71 to 80% of participants selected and backed it. No single voice could overcome systemic opposition. Turning trust into influence requires alliances. 4.8. Lab leaders should have coaching qualifications. Football no longer assumes that the best players will naturally become the best coaches. Even a World Cup winner must hold a UEFA Pro license to manage in the English Premier League. Science has no comparable prerequisite. The main qualification for running a laboratory, supervising grants, and taking responsibility for researchers' well-being remains a strong publication record. Graduate surveys repeatedly identify supervision as one of doctoral students' greatest sources of dissatisfaction. High-quality laboratory leadership courses already exist, but are rarely compulsory. Funders and universities should follow football's example and make accredited management training a condition for leading a research team, creating an equivalent of the professional coaching license for principal investigators.
Section 5. Artificial Intelligence, Computing and Information Governance. This section examines both the capabilities and risks of artificial intelligence, including unequal privacy exposure in medical AI, universal cell embeddings, large language model forecasts of social science experiments, and an AI tool that can resize natural proteins. 5.1. Disparate privacy risks from medical AI. Medical artificial intelligence models could expand access to high-quality diagnosis, but the data used to train them often contains sensitive patient information that can be exposed through privacy attacks. Researchers conducted one of the first patient-level privacy audits of diagnostic medical artificial intelligence, focusing on membership inference attacks that attempt to determine whether a person's data were used for training. Across several medical datasets, attack success for some patients approached 100%, even when overall performance was no better than random guessing. As model capacity increased, the number of highly exposed patients rose sharply. Underrepresented groups defined by disease status, self-reported race, insurance, sex, or imaging protocol were especially likely to face high attack success. Average privacy metrics, therefore, seriously underestimated individual risk. Differential privacy can reduce that risk by adding carefully calibrated noise during training or fine-tuning and limiting the influence of any one patient. It can provide mathematical protection for every contributor, including people whose records are unusual. Experiments confirmed that stronger differential privacy reduced membership inference success for all patients. Protection must be applied at the patient level, not merely to individual records, and recent work suggests that strong guarantees can be achieved with only small losses in predictive performance. 5.2. Privacy risks from medical AI are not shared equally. Some people leave a much stronger trace in a model than others. The study showed that a small number of individuals could almost always be identified by membership inference attacks, even when average risk across all records looked close to random. Underrepresented groups may therefore face not only poorer model performance, but greater information exposure. Protection must focus on the most vulnerable people rather than merely lowering the average attack rate. Differential privacy limits an individual patient's influence on model parameters and provides a mathematical guarantee to each participant. When one patient contributes several records, protection must treat the patient, not each record, as the unit. Privacy audits should report patient level, group level, and overall risk and make clear what membership in the training population reveals. The privacy costs of medical artificial intelligence are not shared equally. 5.3. Universal cell embedding provides a foundation model for cell biology. Researchers introduced the Universal Cell Embedding Model, or UCE, a foundation model for single-cell gene expression that can represent new datasets without fine-tuning or retraining. UCE was trained on more than 36 million cells from thousands of experiments, multiple tissues, and 8 species. It learned a unified space in which cells from different datasets were arranged by biological similarity. The model could generate zero-shot representations for new data, allowing researchers to perform clustering, annotation, integration, and similarity search without training a separate model for each dataset. A foundation model does not eliminate every bias in single-cell data. Imbalances in species, tissues, and disease states within the training data can shape the representation. Relationships produced by the model must therefore be checked against experiments, histology, and functional evidence.
5.4. Large language models can predict the results of social science experiments. Researchers assembled an archive of 70 pre-registered, nationally representative United States survey experiments covering 469 treatment effects and 119,330 participants. GPT-4 had a training data cutoff that preceded publication of many of the studies. Its predictions correlated strongly with the observed treatment effects and were about as accurate as pooled human forecasts. However, the model systematically overestimated effect sizes. It could predict direction and relative strength reasonably well, but its values could not be treated as actual effect estimates. Using inflated effects to calculate sample sizes could leave studies underpowered. Large language models could also be used to design harmful interventions, such as finding messages that best mislead the public, deepen prejudice, or manipulate political attitudes. They cannot replace real experiments, and their predictions require calibration, independent validation, and clear limits on use. 5.5. This AI Raygun can shrink proteins, making editing easy. An artificial intelligence tool called Raygun could shrink or enlarge natural proteins without destroying their shape or function. It reduced the amino acid count of some proteins by 15 to 20% while preserving structure and activity, and in some cases halved or doubled protein size. Further compressed versions of mCherry and EGFP retained their characteristic shapes and fluorescence while becoming smaller than almost all comparable proteins in major databases. This showed that the model could do more than modest trimming. It could search for compact designs suited to particular applications. In the opposite direction, Raygun generated an enlarged epidermal growth factor that bound more strongly to its receptor. The results were encouraging, but it remained unclear whether the tool could perform other types of editing or work across a broader and more diverse range of protein families. 5.6. LLMs can predict social science results. In a study of 70 survey experiments, model forecasts correlated significantly with observed treatment effects and were almost as accurate as pooled human predictions. However, the model systematically overstated effect size. It might correctly identify which intervention would be stronger while exaggerating the true difference. Researchers could use such forecasts before recruiting participants to screen materials, refine hypotheses, estimate sample size, or select interventions worth taking into expensive field trials. The same ability could also support harmful goals, including the search for the most effective misinformation or manipulative content. Models should be treated as forecasting tools, not substitutes for human participants. Predictions must be calibrated against real data, with model versions and prompts disclosed and errors assessed across population groups.
Section 6. Society, Behavior, Language and Attention. This section focuses on attention, language, information and decision-making, including phone use and task switching, information warfare involving governments and technology platforms, long-term changes in language diversity, genetic predisposition and criminal responsibility, and how the zebrafish brain converts recent experience into current choices. 6.1. Science-backed tips on how to avoid distraction. According to a United States mobile service and internet comparison site, American adults checked their phones an average of 186 times a day, about once every 5 minutes. They spent 5 hours a day on smartphones, equivalent to 76 days of screen time each year. The brain cannot consciously attend to two things at once. So-called multitasking is rapid switching between tasks, and every switch carries a cost. Multitaskers make more mistakes and take longer because they must rebuild the mental plan for the task each time attention returns. Researchers can put phones in a drawer, another room, or a timed lockbox, and can use digital wellness limits. They should rest when attention begins to fall, use lunch for recovery rather than filling it with meetings, and take outdoor walks without a phone. Specific goals also improve attention. In a study of 108 American university students, those given concrete, difficult but achievable goals had shorter interruptions and remained engaged for longer than those given vague goals. Laboratories can create protected periods without interruption, distinguish urgent messages from those that can wait, reduce unnecessary meetings, and let people perform their hardest work during their own attention peaks. 6.2. The information state. Jacob Siegel had served as a United States Army officer in Afghanistan, an experience that helped him recognize information warfare techniques. His book accused the United States government and technology companies of forming partnerships after 2001 for the global war on terror, and later turning those systems inward through a war on disinformation. Rather than reforming Internet infrastructure, these partnerships made the Internet serve their own interests. Archives from the social media company Twitter, now X, documented this shift. 6.3. Thousands of languages lost since the dawn of farming. The analysis suggested that language diversity continued to rise for thousands of years as agriculture spread and peaked about 2,000 years ago. There may then have been tens of thousands of languages, roughly 10 times the number spoken at the end of the last ice age. By 1000 BCE, that expansion had begun to reverse. Most languages may have disappeared within a single millennium as powerful monolingual cultures expanded through conquest and trade. These estimates remain an initial hypothesis, and migration, climate, and other factors could change the result. The decline continues today. About 5 billion people speak one or more of just 10 languages, while an average of roughly 4 languages stop being used each year. Symbols do not fossilize.
6.4. A thalamus, brainstem attractor network, drives history-biased decisions. Researchers trained juvenile zebrafish to avoid obstacles in virtual reality while imaging the whole brain at single-cell resolution. Responses to identical obstacles depended on the positions of earlier obstacles. When the current obstacle appeared on the same side as the previous one, avoidance was stronger and the fish moved farther away, whereas alternating sides produced weaker avoidance. Whole brain imaging showed that the dorsal thalamus acted as a memory buffer, using discrete attractor dynamics to preserve a stable trace of the most recent sensory event. A downstream brainstem integrator read the thalamic state and combined it with current visual input to produce a graded response reflecting the history of several trials. Optogenetic perturbations supported a causal role for both regions. Disrupting the thalamus weakened historical memory, while disrupting brainstem integration changed how past information influenced current avoidance. 6.5. Original Sin. A 2021 study co-authored by psychologist Catherine Page Harden analyzed genetic data from 1.5 million people. Some DNA sequences were more common among people with addiction problems than among those without them. In her book about the causes of human wrongdoing, Harden argued that treating genetic influence as proof that a person cannot change is another legacy of the doctrine of original sin. Her thinking was shaped by the Christian upbringing she later left. Like original sin, DNA does not determine that a person will commit a crime.
Section 7. Quantum Science, Physics, Materials and Chemistry. This section spans quantum information, condensed matter physics, photonics, synthetic chemistry, and materials circularity, including quantum entangling gates, carbon dioxide-based circular polyesters, field-enhanced superconductivity, multi-lane topological photonics, ferroelectric polarization, living fungal textiles, and the sound of underwater bubbles. 7.1. An entangling gate for dual-rail erasure qubits. One way to reduce the demands of quantum error correction is to design qubits with a clear error hierarchy, so that the most common noise channel is also the easiest to correct. Researchers designed and implemented a 2-qubit entangling gate for dual-rail cavity qubits, which encode information in a pair of superconducting microwave cavities. The experiment confirmed that the gate largely preserved the original error hierarchy and operated in about 500 nanoseconds. Each operation had an erasure rate of about 0.5% and a residual Pauli error rate below 0.1%. The noise was strongly biased toward dephasing, with bit flip errors almost absent at the part per million level. 7.2. Alternating CO2 and bicycloalkane copolymerization to circular polyesters. Researchers built a closed-loop polyester platform based on carbon dioxide, directly alternating carbon dioxide with bicyclobutane and bicyclopentane monomers to produce high-performance, recyclable polyesters. A simple organic catalyst initiated fully alternating copolymerization, and carbon dioxide made up as much as 50 mol% of the material. The bicyclobutane polyester combined excellent thermal and hydrolytic stability across the acid-base range, with selective depolymerization recovering pure bicyclobutane monomer at an isolated yield above 90%. The bicyclopentane polyester could also be selectively depolymerized, producing a bicyclic lactone. Repeated depolymerization and repolymerization showed that both materials could operate in a circular life cycle. 7.3. Family of magnetic field-boosted superconductors in rhombohedral graphene. Researchers measured transport in rhombohedrally stacked 4-layer and 5-layer graphene and observed a group of superconducting states in the clean limit. In 5-layer graphene, they found 3 forms of magnetic field enhanced or magnetic field induced superconductivity that remained stable under in-plane fields as high as 8.5 Tesla, tens of times above the Pauli limit. The main results were reproduced in multiple 4-layer and 5-layer devices, in different laboratories and in different cryogenic systems. Rhombohedral multilayer graphene therefore formed a new family of field-enhanced superconductors with low gate requirements, ultra-clean crystals, and interfaces that can incorporate spin-orbit coupling for studies of topological superconductivity and non-abelian quasiparticles. 7.4. Insulator-free topological photonic multi-lane highways. Researchers proposed an insulator-free topological waveguide that removed the usual trade-off and enabled multi-lane one-way light transport with 100% spatial utilization and topological protection. Experiments and theory showed that the structure transformed conventional edge states into densely arranged one-way modes covering a broad area. Propagation directions alternated across 4 regions, while light remained robust through sharp turns and major changes in shape and was not easily backscattered by defects. The design offered a route to ultra-compact topological photonic circuits and high-density integrated optics. 7.5. Ligand-enabled distal desaturative lactonization of aliphatic acids. Researchers designed an O-allyl hydroxamic ester ligand that enabled a palladium catalyst to activate gamma-position methylene and methane carbon-hydrogen bonds in common fatty acids and cyclic carboxylic acids. The method directly converted aliphatic carboxylic acids into remotely unsaturated gamma-lactones and doubly desaturated gamma-spirolactones. The products carried unsaturated sidearms and served as important intermediates for complex natural products and medicines. Starting from common heptadecanoic acid, the team rapidly synthesized an ananaceous acetogenin and related compounds in 3 steps and evaluated anti-cancer activity. Combining lactonization with remote desaturation improved step economy and atom economy and opened the sidearms to further functionalization.
7.6. Non-epitaxial perovskite polariton laser diode operating under direct current. Researchers integrated solution-grown cesium-lead bromide microplates with chemically inert single-walled carbon nanotube electrodes and placed them in an optical microcavity. When cooled to 8 Kelvin under constant current, the device formed a perovskite positive intrinsic negative diode that balanced electron and hole injection at high current density. The microcavity diode operated in the strong coupling regime and produced polariton lasing under a direct current of 65 microamperes. The experiment still required low temperature, and stability, lifetime, manufacturing consistency, and room temperature performance remain to be improved. The result showed that solution-processed semiconductors can achieve continuous electrically pumped coherent emission in an integrated microcavity. 7.7. Perpendicular switching of polarization in layered ferroelectrics. Researchers found that in layered bismuth tauetonate, in-plane and out-of-plane polarization were coupled through oxygen octahedral tilting and rotation, allowing perpendicular switching. In an epitaxial film oriented along the crystal C-axis, an out-of-plane electric field deterministically reversed the in-plane polarization. When the out-of-plane polarization changed direction, the oxygen octahedra rearranged cooperatively and carried the larger in-plane polarization with them. This cross-coupling allowed conventional top and bottom electrodes to control horizontal polarization without lateral electrodes or high voltage. The approach provided a materials platform for capacitive computing, low-power memory, and new ferroelectric device concepts. 7.8. It'll grow on you, a textile made from fungal filaments. Scientists turned fungal filaments into a self-cleaning living textile for packaging and sustainable fashion. They grew Cordyceps militaris into a dense mycelial network and used chemical treatment to make the material flexible. When clothing developed holes or tears, nutrients and fresh fungal material could be added so that the filaments continued growing over the damage. Pigment-producing yeast gave the material pale blue, red, orange, and purple colors without environmentally harmful synthetic dyes. The living material was biodegradable, and a small sample decomposed in soil within 41 days. 7.9. Semiconducting and magnetic lanthanide MXins from intercalated halides. Researchers developed a general bottom-up method that used layered lanthanide monohalides as van der Waals building blocks to synthesize chlorine or bromine-terminated gadolinium, terbium, dysprosium, holmium, erbium, and lutetium MXins. The multi-layer materials combined semiconducting and magnetic properties tunable through the lanthanide element and surface termination. At 2 Kelvin, the samples showed ferromagnetic hysteresis with Curie-Weiss temperatures from 6 to 59 Kelvin. The results expanded the composition space of MXins and integrated electronic and magnetic functions in one two-dimensional material. The coexistence of semiconducting and magnetic behavior made lanthanide MXins candidates for spintronic devices. 7.10. Dipoles go sideways in thin ferroelectric film. Bismuth titanate films coupled vertical polarization between the top and bottom surfaces to much larger horizontal polarization, allowing a small voltage to control a large, stable state. The study showed that the small out-of-plane polarization and large in-plane polarization were linked through distortions of oxygen octahedra. Reversing the vertical electric field first switched the out-of-plane polarization, triggered a cooperative octahedral rearrangement, and then reversed the in-plane polarization. Conventional top and bottom electrodes could therefore control in-plane polarization at lower voltage. The sideways switching of dipoles showed that orthogonal polarization coupling can use conventional device geometry to control an otherwise difficult in-plane ferroelectric state. 7.11 Imaging of nanoscale polar textures in quantum paraelectric SRTIO3. Researchers used low-temperature scanning transmission electron microscopy to cool strontium titanate foils to 20 Kelvin and directly image their low-temperature polar structure. High-resolution images revealed a spatially fluctuating landscape of nanoscale domains. Below about 105 Kelvin, short-range polar domains first organized into periodic structures extending for tens of nanometers. When the temperature fell below 40 Kelvin into the quantum paraelectric regime, this process reversed and the ordered nanodomains fragmented into smaller clusters. Quantum paraelectricity therefore did not mean an absence of local polarization, but polarization forming, ordering, and fragmenting again on the nanoscale. 7.12 Bursting bubbles, why some are louder than others. Underwater bubbles make sound, and researchers identified the physical mechanism that determines loudness. They created bubbles either by releasing air through an underwater nozzle or by dropping water onto a pool surface so that a dimple closed around trapped air. High-speed cameras and an underwater microphone showed that the smaller bubbles formed by dripping were often louder than the larger bubbles made by the nozzle. The faster a bubble changed size, the louder the sound. This relationship could allow researchers to infer information about bubbles from sound alone.
Section 8. Ecology, Evolution and Paleontology. This section presents life as a network of interdependence. One article examines how parasitism and symbiosis participate in disease, decomposition, material cycling, and evolution. The other uses high-fidelity modular skeletons, regular zooid arrangements, and membranous sacs to support a Cambrian origin for bryozoans. 8.1 The Secret Relationships That Govern Life on Earth. 2 books explored the relationships connecting all life. Communion argued that cooperation between species is a major force in evolution, while Secret Creatures took a darker view, emphasizing that life feeds on life and that about half of all organisms live on or in others. Parasites can even drive hosts to suicide, as horsehair worms alter gene expression in a mantis brain and make the insect jump into water so that the worm can reproduce. Lichens also showed that the boundary of an individual is not clear, because what appears to be one organism is a partnership in which algae supply sugar and fungi provide water, minerals, and a protected structure. 8.2 High-fidelity modular skeletons authenticate a Cambrian origin for bryozoa. The Cambrian explosion produced the major animal body plans, but bryozoans had long remained a conspicuous exception. Researchers described new specimens from Cambrian strata in China that preserved high-fidelity modular skeletons, colonial organization, and membranous sacs. High-resolution X-ray tomography revealed internal cavities, zooid arrangements, and budding patterns. These skeletal microstructures and modular growth features linked the fossils to bryozoans rather than merely giving them a similar outward appearance. The results supported a Cambrian origin for bryozoa and filled a long-standing gap in animal evolutionary history.
Section 9. Mathematics, Scientific Lives and Academic Culture. This section records scientific lives and academic traditions. Susumu Tonegawa explained antibody diversity through gene rearrangements and later transformed memory research through engram cells. 4 Fields medalists advanced fluid equations, contact geometry, Shimura varieties, and the Kakea problem, while a short review of geology showed how rocks and life explain one another. 9.1. Susumu Tonegawa. Susumu Tonegawa was a renowned neuroscientist who transformed understanding of learning and memory and also made a major contribution to immunology by discovering the genetic mechanism behind antibody diversity. In 1976, he reported that antibody-producing B cells rearrange their own genes, expanding the number of antibody proteins humans can make from roughly 25,000 to billions. His laboratory later showed that memory engram cells could be programmed to manipulate memories, create false memories, and even retrieve memories in amnesic mice. Those days have passed, but Tonegawa's achievements and the many people they inspired continue to live on. 9.2. Rising Stars of Mathematics awarded 2026 Fields Medal. Mathematicians Yu Deng, Hong Wang, John Pardon, and Jacob Timmerman received the 2026 Fields Medals, covering fields from number theory to mathematical physics. Deng's best-known achievement solved one of the problems that David Hilbert presented at the 1900 International Congress of Mathematicians. Pardon later worked mainly in symplectic and contact geometry. Zimmermann and his collaborators proved the André-Oort conjecture, a central statement in the theory of Shimura varieties. Wang's best-known work answered a version of the problem posed by Soichi Kakea in 1917. 9.3. Geology. Biologist David Bainbridge had spent his life fascinated by animal structure. In this history of geology, he used examples including dinosaurs to show how biology and geology have long been intertwined. Rocks reveal the setting in which organisms lived, and organisms reveal the setting in which rocks formed. Charles Darwin's work also embodied this relationship. The book was divided into 5 main parts: time, energy, process, uses, and life, each supported by wide-ranging illustrations and detailed explanations.
All right, we are now ready to enter today's main program. Before we do, please like, save, and share this episode so that other people who need it can also see today's content and become better versions of themselves. Thank you. You can now use the timeline in the video description or the pinned comment to find the articles that interest you and listen to them in depth.